And I'm really, really excited about our next speaker. Javier Fuentes Alonso is the head of machine learning at Uizard, a company developing AI-driven tools to transform the way people design software. And he's been like a long-standing expert in the field of computer vision and is applying that now to solve problems in the field of design. So something that hopefully for a lot of us non-designers can be very helpful in the future, that we can also create beautiful software, even if we are not native designers. And in his talk, he's going to share exactly that, how machine learning can turn you into a designer. Welcome, Javier.
Well, hello everyone. My name is Javier Fuentes Alonso, and I'm the head of machine learning at Uizard. And today I will be telling you about how machine learning can turn you into a designer. But first, let me start by explaining you a little bit how is the current workflow for creating an app or website. So it looks a bit like this. You usually get your user needs, then you also have a stage of wireframing, developing the UX design for it, testing it, then do some colors and designing the different components, so the UI design, and finally all the development, and then you deliver your product. And if you have never worked with this, you may expect that it looks something like this, but the reality is way messier than that. You go back and forth from all the different stages. You learn more about the problem, which makes you revisit different parts. A new stakeholder appears that changes all the process. And it's not only that, it's that, as I was saying, there are a lot of different stakeholders here. But in order to really approach this problem, we need to understand why is it that this is so messy. And the truth is that it's inherent problem to the design process, because the design process looks very much like this. It's like a maze where you are in search of a solution, but there are so many different ways of approaching it that you will find yourself in situations where you end up in a deadlock and you cannot move forward. And that means that you need to come back to your job, redo a lot of these parts, which indeed becomes time-consuming and costly. So we at Uizard, we were thinking about this problem, and we were wondering, can we actually leverage machine learning to accelerate this search problem and in general the workflow of creating apps and websites? And with this idea in mind, how Uizard started was thinking about solving this particular problem. Can we take a picture of a wireframe and then convert it into a design, like the high fidelity design of it automatically? So the idea will be that anyone can just draw wherever they want in a piece of paper, in software, a rough sketch of how their app will look like. And then we leverage all of these cool technologies, machine learning, computer vision, language modeling, in order to get basically finalized, ready to test app. So yeah, we started working on this project. And at the beginning, when I first started working on this, I have to admit, I was a bit naive, because I thought, how difficult can this be? Maybe I spent too much time in academia, or I read too many papers, but when I read hand-drawn, the first thing that came into mind was MNIST. And we all know MNIST is simple. It's the baseline for all our models, right? So yeah, this seemed to me that it was going to be basically arranging some MNIST digits, maybe, draw some lines in there. And okay, you may have to change the symbols for something more domain specific, but it should be doable, right? Well, it turned out to be a bit more difficult than that. And to exemplify this, I'm going to explain you a bit of what's a line in our domain. So usually a line it means some sort of text component. These text components are sometimes grouped together, sometimes because of visual reasons, quite obvious ones, but other times is more because of like how they're arranged together, and it's not obvious. Different people will have different opinions on how to group them. Even worse, some icons are even groups of lines as well. Sometimes these groups of lines can also be broken because some other components appear next to them. And sometimes can be broken because new lines with completely different semantic meaning appear between them. These lines can also be affected by their parents. What is it containing that line? As is the case of a button, it will have a different semantic meaning, but they can also act as some sort of modifier for other text, as is in the case of an underlined text. And if you take into consideration all the context of what the wireframe is about, and even like what's written on those in this text, it can even become an input field. So it's quite complex already, but then you need to bring this into the real world. And then in the real world, even the paper that you draw in have some lines on it. And in the paper that you're drawing in, there may be even transparencies from the previous wireframe that you drew before that also have lines on them. In the real world, there is also way more lines than in these simple examples, which of course complicates things. And there is a lot of weird stuff, let me tell you. There is people drawing wireframes in a greasy pizza box, or people trying to sketch some ideas in a sandy beach with a stick. So, yeah, turned out that this problem was quite complicated from a machine learning perspective. And one of the main reasons that makes this complicated is that the visual representation doesn't mean semantics. And this is a common problem, not only for this particular task, but in general for any sort of task in the design field, as well as any sort of task that involve sketches. And as an example, you have here 3 different wireframes with the same semantic representation, but completely different visual representation. And this is because, like, us as humans, we draw on an abstraction level that is not common for all of us. And yeah, this complicates things quite a bit. But the good thing is, like, once you get over all of these, or at least some of these problems, you get quite an interesting product, because you are able to allow everyone, by just sketching something in a piece of paper, to continue their journey in a few seconds, doing prototyping, both low fidelity and high fidelity, whatever they're interested in. So yeah, we developed this in Uizard and it started to work quite well. And we allow our users to play with it. And of course, we allow our users as well to modify how their branding will look like, all the colors and all the different components that are used, how will they look like. So we were expecting that the wireframes that they will convert, they will look something like this. nicely designed, but the reality is that it looks something more like this. And it's no surprise because most of our users are non-designers who don't know about all the complexities or creating a compelling brand image, all of the color matching, all of the typography choosing problems. It's a really complex problem. So we went back to the drawing board basically, and we started thinking, okay, can we actually help them also with this side, with the part of choosing the colors, of choosing the fonts, and so on. And this is how a new project emerged. That's something that we call the theme extraction. And the general idea is that most companies already have some sort of design assets with them, maybe in the sense of a screenshot, but maybe in the sense of some design files where there may be some landing page there or any sort of asset already. So maybe we can just, again, build a new pipeline to recognize all of the different components that are there, extract all of these color properties, and so on and so forth, and bring them into Uizard so that they can start prototyping really fast. So yeah, we started building this, and then we said, okay, can we actually take this a step further? What happens when you are starting a design process? When you're starting a design process, you're just exploring different opportunities for your product. And if you want to implement all of these different designs by yourself, it will take you a long time. But what if we can just drop an image of something, some color palette that you like, some mood board that you like, and then we create a nice theme for you? But the challenge here is that you need to make a good-looking theme, right? It cannot be like the previous one that I showed you. And we started working on this. So as a machine learning engineers, we were like really trying to follow best practices. So we started by making a test set. We want to know how well we are doing, how our algorithms are evolving over time. But in order to create this test set, first we need to define what is this good-looking target that we are aiming for. And let me give you an example of something that our test sets could look like. Let's say that this is an input that we will get, and then we need to define our target label for it. So which theme do you think that we should create? Which of these themes are more good looking? And truth is, I don't really know. And it depends. Different people will choose different one. It's quite complex, right? So we said, okay, let's actually do some literary review and read a bunch of papers about this topic. I bet that people have been studying this. So let's take a look. And surprisingly, it turned out that it's really difficult to define mathematically. And to exemplify this, we found this survey paper where they go through different design metrics for particularly user interfaces. And they found 26 different concepts, as in alignment, balance, color complexity, color matching, that influences how good looking something is. And even within these concepts, they have 64 different metrics. So there is no agreement on how to even implement these different concepts. And of course, zero good looking metrics, no single metric to optimize for. And we start to see here some of the problems that come to applying machine learning to the design field. And that is that there is a lot of ambiguity. Which test groups should we aim for produce here? It's like the one on the left or the one on the right? Depends. And which themes should we try to generate? Yeah, it depends. So it turned out that the most difficult part of applying machine learning to design is actually what makes design difficult on itself. And to exemplify this, I really like this quote from this famous blog post called "Why Design is Hard." And it goes like, unlike in an algebra problem, in design, no solution is the unique correct solution. Instead, many feasible solutions exist that possess characteristics that are better or worse than other solutions. And this realization really, really affects a lot of the approaches that you take when designing these machine learning pipelines. There are a lot of things that you cannot do and a lot of things that may become easier, but other things that become way more complicated. But yeah, we went through all of this, worked through all of these problems, and at the end of the day, we ended up with a really cool solution where anyone can just drag and drop any sort of image, and they will get automatically the UI design for it. And this is very nice, not only for non-designers, our main target group, but even designers struggle with it. I've heard designers complaining that creating a new design system with all of the colors, all of the deciding whether if a button has a line or not, and so on and so forth, will take them weeks. Or even like when they're migrating tools, and you already have all the design, it will still take you a long time. And I know what some of you may be thinking. Doesn't that mean that robots are taking over? Doesn't that mean that all of these people that used to be involved in this process will now be losing their jobs? And before you jump into conclusions so fast, I would like to actually reflect on the advances that we have seen on a field that we are all very familiar with, deep learning. And in my opinion, what we are seeing is a really similar process that we are seeing in design, and is the democratization of it. So let's start from the beginning. 2012, by a lot of people, were considered the beginning of the deep learning era with the AlexNet paper. And in order to implement this AlexNet paper, they had to spend months defining absolutely everything in a really low-level language like CUDA, how to do backpropagation on every single step, and all of this for an architecture that we now consider simple. But thankfully, our tooling improved. 2015, we got the release of TensorFlow, which allowed us to not having to define these low-level functions for every single small experiment that we do. It also allowed us to play with it in Python, which is great. And don't take me wrong, it was by no means perfect. Debugging was really difficult, but it was definitely a step forward. And since then, we have kept improving. Then we got PyTorch, we got the higher level libraries like Keras and FastAI. 2018, we got the release of FastAI V1. And the interesting part of this is that they marketed themselves not as the next tool for data scientists or engineers. They market it in a way that they say, this is a deep learning tool for coders. That means anyone can use it. If you know how to code, you have access to state-of-the-art deep learning models. And this is a process, right? The trend will continue, and I don't know how it will be in 2025, AutoML. I don't know, but the trend is clear. We are going from really expert systems to more mainstream systems, from tooling that requires a high learning curve and that are hard to use, like CUDA, or low-level languages like C, into a more mainstream, low learning curve, easy to use tools. And this doesn't mean that if you can do backpropagation by hand and that you can implement all of these complex algorithms by hand, you're gonna lose your job anytime soon. You will still be required in a lot of different problems. But what this means is that we now have a new group of people that have access to all of these higher level tools that allows them to create products by just calling model.fit data. So again, this means that this expert tooling that was used for, or is currently used by PhDs, by hardcore engineers, is now democratized so that any data scientist, any engineer, even like domain experts with a little bit of coding experience can develop state-of-the-art deep learning models to some extent. And as I was saying, this is something that we are seeing also for design. Up until now, we are relying on designers using a high learning curve, hard to use tool in order to make this work happen. But we believe that with a machine learning assistant tool, we can lower this learning curve and make it much easier to use. And this is because in these designer tools, the person does the hard job, but in a machine learning assisted tool, it's the technology doing the hard work, as we have just seen. And what this causes is that this tool is not only for UI designers anymore, but also for product people, or maybe you're a founder that would like to express their ideas, or even like a developer. So I don't want you to think about the future of design as something like this, but more like this, where it's very much assisted. And this doesn't only mean that people will be able to go through the search space of solutions much faster, but it also means that some people will get empowered. Maybe you are a domain expert that before you thought this is such a big problem to create a product, but now you are able to do a lot of these steps by yourself. So that means that you can start your company. Or maybe you are a developer that wants to kick off a new product. And this is all possible because we now have the technology that allows us to go from what used to be just some rough sketches, some lines in a piece of paper, to an actual prototype that a designer can make, or just some images of umbrellas into an actual good-looking theme. In other words, we have now the technology that allows us to go from our noisy world to our way more structured technological world. Or in other words, machine learning becomes the interface. Thank you.
Hey, Javier. Sorry for a slight delay. You finished a few seconds earlier before I imagined. So you're definitely more German than myself, being like right ahead of time. So thank you so much for your great presentation. First of all, you've definitely awed the audience. So as Anna Maria has shared, like in the chat, it was really cool what you demonstrated and showed. So kudos for that. It seems there's even hope that I can be a designer one day with the use of machine learning and AI. So very, very impressive. And please, for anybody in the audience who wants to know more, definitely post your questions as I'm going with Javier through a 4 or 5 minute Q&A. So the first thing that I want to ask you, right? And we've chatted about this a little bit before, but so there's now with Clip and a lot of the latest advances that OpenAI has posted with generative models. I think you've shared some of the stuff where you transform wireframes into production graphs. But what do you see happening in the next 2-3 years as the main trends? Because you shared a little bit the progress of how far AI has been democratized in your talk. But what are the main trends you see in the next 2-3 years happening?
I think that we will continue with the similar trend. We will continue seeing, on the technical level, the trend is clear. Bigger models that generalize is better, and that may also affect the design field. We have seen demos of people trying to apply GPT-3 to generating apps and so on, or even generating code. And I think that particularly in the segment that we are serving, which is non-designers, all of these, it's really valuable because, as I was saying before, you don't need to learn complex user interfaces. You can just write what you want, which it's a way of really empowering these people, right? Anyone can design now.
Yeah, no, I think that is indeed super, super powerful. So do you see that, and sorry if I missed that. So do you see that basically this is going forward, being integral part, even of content management systems? Do you see this more generating apps and pages, or do you see this really used even within designing individual articles and blogs and stuff like that? Where do you see this ultimately being integrated?
I mean, I think that when it comes to design, usually the user experience is something that you spend more time when it comes to apps and websites than when it comes to articles. But I definitely see some potential there. And again, it's something that we are seeing a lot when it comes to GPT-3 generating whole blog posts from just a couple of points, or generating copywriting ideas. And I think that it will also very much be connected between them, in the sense that you may be able to design and at the same time work on the content and optimize all of these together with some machine learning help.
I would love for imagery and graphics and illustrations being automatically generated for a blog post. I think that would be super cool. All right, sorry, I'm just checking if there's any other thing. You're getting just a few kudos from some of the people in the audience, from Gemma, Esdras. They're all very impressed. I'm just scanning through if there's any questions, but I think you've done a fantastic job at answering all the questions from the audience. So I'll just close with one question in the broader field of machine learning. What is the thing over the last 12 months that you've seen that has impressed you most, that you said people in the audience should pay attention to?
I think that in the last 12 months, actually you just mentioned it before, I think that Clip, this vision model, mix of language and vision model from OpenAI, I think that it has been one of the main milestones. I think that up until now, computer vision has been falling behind a bit on all of these self-supervision trend. Well, this is not self-supervision per se, but this trend of really general models that as GPT-3, you can just create products without having to retrain it, and all of the cost that this leads to. So I'm really excited with all of this new trend where you don't need to go through all of the machine learning work that it means creating these complex products, and that you can just maybe call an API, and that means that a lot more products will benefit from these really cool technologies.
That's a great vision for the future. And I do personally playing very much with the OpenAI APIs has like been fun playing with them over the last few weeks since I got access. Anyway, thank you so much, Javier, for joining us. Great having you.
It was great being here.